Oh, yeah.
Why?
So what this is going to do is when we move things up into the cache, we're going to move them in very specific ways. So the way that we know that this is block 1 and block 2 is if we look at this, let's see, we've got our cache, which is has a block size of 8 bytes. So we know that it's got to be, we're going to split it down the middle here because you can only have 8 bytes in a block. And then it chunks it 8 byte block by 8 byte block, as we can see in that third bullet point. So we chunk block 1, then block 2, then block 1, then block 2. So we just kind of alternate like that.
So it's not dependent on the fact that the block 1 is organized.
Yeah, so
it's not dependent.
yeah, so the blocks are not dependent on the rows. So if we look at block 1, we can see that there's kind of a pattern here where in block 1 we've got all of the 0 row of both source and destination. That is a coincidence. We have to look at the block size. Is that clear how we kind of constructed this? Okay, cool. That's kind of your hardest challenge on this kind of problem. So the next thing we're going to do is we're going to draw out our cache. So we know our cache is, let's see, 16 data bytes. So, and then our cache again has 2 blocks. So we've got our 16 bytes here for 8, 12, 16, and this is going to be block 1. And this is going to be block 2. So now whenever we want to move, or whenever we move things into the cache, we're going to move whatever's in the cache. If we pull it from block 1, we're going to put it in cache block 1. And if we pull it from main memory block 2, we're going to put it in cache block 2. Okay. So we're just going to keep that there and keep track of kind of what goes in the cache. We know that our cache starts out empty. So the next thing to do is look at the code. So we're going to move through the destination and the source array through those 2 for loops. The next kind of really important thing to realize is that we're always going to pull the source first, because if you look at how the code is written, we're going to set the destination ij equal to the source. So we actually need to pull in the source and get that, get its value before we put it in the destination. So even though the destination is written first, you always pull from the cache. You pull that source first, or whatever is going to get put or get set equal to the other one. Alright. So as we move through that loop, the first thing we're gonna in iteration 1, the first thing we're gonna pull into the cache is source 1 minus j 1 minus I. So since I and j are rules at this point, we're gonna pull in source 1 1. So we look in our main memory and we find source 1 1 over in the top right. And we're going to pull in that whole cache block. Since that's in block 2, it's going to go in our cache block 2. So we're going to pull in source 1 0 and source 1 1. And now we have our first answer in this kind of array that we've got. Since source 1 1 was not in the cache and we brought it up to the cache just now, it's a miss. So we can go ahead and fill that in this source array. So now we're still in iteration 1 of the loop, but now we're looking for the destination array. Looking for destination of 0 0. So we go in here, destination 0 0 is in block 1 of main memory, so we're going to bring it into block 1 of